Hi, hello everyone. My name is Sandhya and I work on Watson. I'm really excited to be here at DevOps. And you know all my colleagues, Stefan, Daniel, Jim. So we are going to take you through a Ask DevOps prototype that all of us have been working on for quite some time. The order of the presentation would be, I would like to go through natural language processing and natural language classification using Watson, and then Stefan.
Yeah, so I'll show you the conversation and retrieve and rank configuration that we've used for the Ask DevOps demo. So it's going to be an interactive slide, a browser session.
Yeah, on my side, I will just show you the integration of Pepper to the REST services that we have also developed with James. So, James?
And I'll show you an orchestration service created with Spring Boot that then is the kind of a server that then interacts with, allows Pepper and Amazon Alexa and other clients to interact with the cognitive computing backend. And also specifically, I'll show you some things about Alexa and how to do some programming with Alexa.
And then we'll probably, depending on time, do some Q&A. So if you still have questions, then we can make it interactive.
Yeah, let's make it an interactive session because we have had fun developing this prototype and would like you to join us in exploring further. So let's begin. Natural language processing, you all have been attending many awesome sessions during DevOps so far. It is a very neat subject, and there are lots of underneath research that goes on using different kinds of neural networks, namely convolutional neural networks with several layers of dependency trees, using recurrent neural networks with attention layer and several patterns of chunking the representations, both at word level, sentence level. But why? The main thing we want computers to understand is what humans are talking and phrasing in their words and sentences. So it's very important that the computer can understand our questions in human language. And that's what we will go into. And then we also want computers to extract answers from the structured as well as unstructured data, which is just in tremendous quantities available all around us, and it is growing just at a very fast rate. So to curate that content and to glean the answers from that unstructured content is very important for AI. And then, most of all, what is important is that computers should do reasoning. And it's not that they should get word by word something from a document or news feeds. They should be able to reason out and produce an abstractive summarization that may include knowledge that will include knowledge and also words that were not in the document at all. So the computer would be phrasing and producing summaries that are intelligent and based on reasoning. So let's see how that happens. So I would like to take an example to relate to your development expertise using conversation neural networks and conversational APIs. So for that, let's take a look at a conversational bot, which are essentially neural nets trained with intents. And intents are the actions you want to take. So you would want your bot to do certain things based on what you ask. And then you would want to qualify those actions with entities that are nouns as to how the action should be modified based on the input that is coming in. So let's see how that happens. And then comes in dialogue, where you have asked a question to the bot. How does the bot know what is the context of your question and how it answers? So we will see how dialogue nodes are designed. So before I go into the demo, just wanted to mention that as of now, in conversational bots using Watson, we are supporting these languages. And by next month, many more languages are going to be available. And we also, for ease of use, have designed a virtual agent that has predefined intents, because we would like to make it even easier and faster to production with the predefined intents. So, and these are some of the industries where the predefined intents are available. So let's first take a look at a bot. All right. So just to exemplify the features, I took a very simple example and quite trivial one, that is ordering pizza, which I have to order quite often for children at home. So let's just see how this is designed. There are several intents I have added here, and with user examples. So what is the need to add examples in here? You will see that these are just random phrases, but I am just trying to train Watson to understand what this intent is all about. What do I want to do? I want to order a pizza. I may want to change my order. How do I want to change it? By changing size or toppings. So it's just some examples of what I would like to do. And that's why I've added these phrases. And these phrases are taken by Watson to the NLP layer, and it forms a model that when these words come in combined with anything else the human might say, what action it should take. So that's what intents are. Now, just to simplify this example, there are only two entities here because those two are relevant while ordering a pizza. That is size and toppings. So I have given the size values and the topping values. Now, these values are important because Watson takes it into its neural network and says, when this is asked, I'm going to take an action in terms of fulfilling the pizza order. So these values with its synonyms are important. For example, one could say mushroom or one could say mushrooms, but I have to enter those synonyms so that the network knows what that entity means. So lastly, let's go into dialogue. So there is always a conversation start for a bot. And I have just said, hello, welcome. Then I have added certain greetings in here just to exemplify, just to be cordial. And let's take a quick look at this response. It's just simply saying, when I say hello, it's being nice to me, what's your name? And I enter that as an input text. That is saved in a context variable called username. And that context variable can carry on in multi-turn conversations. So that's a powerful concept to keep the context in our conversations so that the human asking the bot does not have to repeat himself or herself over and over. So that's what is going on. So let's now test this bot out right here. Let's say, hello, can I get some help? Now, these words were not entered in or given to Watson, but it can infer what it should be doing. It maps those words to the intent greetings correctly, even though the intent did not have these words. So that's where NLP and NLC kicks in. So it says, may I know your name? Yeah, sure. So that's what I enter, and it recognizes my user input and fits it into the response. So let's order a small pizza with, say, cheese, pepperoni, bacon, right? So it says, yeah, great. I mapped your input to this particular intent, and these are the entities you have given me. Well, then I say, oh, a guest walked in. Can I change to medium, right? I didn't say size or any such thing, all right? So, yeah, I can change that. Now I will give you a medium one with the same toppings. So it sees what input I'm giving and accordingly chooses the dialogue node that we should go to. And that's happening on the fly. So that, I mean, even though it may seem very simple example, but all the principles of NLP are being worked underneath. So if I say change the toppings to something else, let's say spinach, olives, let's just make it gross, and mushrooms, right? Okay. So no problem. It will keep my older size that was medium size with it. It remembers that context and changes the toppings. So that's how this UI tooling is available to us to design very smart bots. In this bot, we can also make a REST API call to some third-party APIs. For example, getting the session information at DevOps, or to be booking flights or anything else. Imagine whatever your industry involves. So that's about conversation. Any questions? Sorry? I did? Yeah, okay, sure. Oh, thanks. Thanks for catching that. So, see, that's how the intents are very important. I misspelled and it could not understand that what entity I meant. So I can say, well, right now it is not adding. I can do an append in my nodes. So currently, it is simply replacing the toppings. And that's how, if you look at, okay, so this is blocking the view. All right. So right now, whatever toppings come in, it just includes that as the ultimate last update, and it is not doing an append here. If I were to do an append, it would be adding the topping. So yes, since I misspelled, I can definitely give it a new list of toppings. Yeah. Yes.
For mushrooms, yeah, she could also give a synonym and have like different misspelled mushroom words, and it would pick it up.
Absolutely. Thanks, Stefan. So yeah, here, so for example, I was being very particular and did not add synonyms that would be are misspelled, but obviously I'm not good at typing, so whatever I did, maybe HS, right? So if this is a synonym, then it would understand. And as soon as I do something like this, Watson does start training, because the entities and the intents are very important for the NLP layer underneath. Any other questions?
There's a question over there, Sandhya.
Yeah.
So repeat the question.
Yeah. If I understood, you're saying, can we ask Watson to generate the synonyms? Currently, it's not possible, but that's where we are going, is to make the tooling even easier. So right now, the human has, whosoever is designing the conversation bot has to enter the synonyms and the values that he or she cares.
I'll just stand next to you, and don't stand so close to the mic, to the video. It's going to scare people, in a good way. Oh, that came out wrong. Sorry. No, it's just like But no, what you can do, there are some websites where you can enter a name and it gives you synonym words. So what you do is just copy those words and you include it into this UI. So you can really do that very rapidly, not only for synonyms, but also for misspelled words. So you can really, this is where you really build up the NLP and feed it, definitely with pizza. And it's very easy to do, but it's a manual task for now.
Yeah, but we are making this easier. So
other questions?
Yes. So if I'm understanding,
the question is,
yeah.
Does it also react on invalid input? How does it behave?
Yeah, so I mean, there are intents, there are system intents like off topic, out of scope, or even true. So if nothing else, no other condition is satisfied, it will fall into the true bucket, which is a built-in intent. And then you can take action on it, whether give some output to the human and say, please give me this input and loop back. So that's what I have done here. Let me show you.
And what's also really beautiful is that because of you have that dialogue, you can immediately start testing and see how it actually identifies the intents and the entities. So it is really like, then you give it just to your son or your daughter, just type some sentences and see how it behaves, and you just really need to add more synonyms, misspelled words, etc. And it becomes smarter and smarter while you're adding more information. So you need to really build it up and train it, so to speak. Yeah, that's then so the question is that if you say medium, it's then a different context, right? So it depends on the conversational context that you can then interpret it in different ways. So it depends then on the context.
Right. So, I mean, your question is that context plays a very big role. The question was like medium size, whereas medium stake. So the contexts are totally different. You can define a different entity to build in the context around stake and how it should be done, medium rare, medium something else. So and accordingly, you can have your variables which will be passed from one conversation to the next. So all the nodes which are sitting to the right of your dialogue node, they are all taken as sibling nodes, and they are you go into those maintaining the context that you have set. So I'll give you an example. So first of all, to answer your first question, what happens when you are making a mistake and you are not really providing to the bot what it needs? So one small example is you have a condition, system condition true, and you can simply say, sorry, I didn't understand. Please give me the size and toppings you would like to order, because this happens to be a pizza bot. So what did I do here? I said, if this happens, then continue from this particular input, which is our starting point. So it is continue from the user input, as you will see in here, this thing. Oops. So it takes me, loops me back, but continue from user input. So that loops me back and I don't have to repeat myself. So your bot can be smart in taking actions. Now the next question was, if we have to continue the context, we can have these sibling nodes, and they will carry the context forward that you have set up here. So my context is the size in here. I will carry it forward to the next node that has the toppings. So in the next node, okay. Here. So in the next node, because I knew the size already, I've used $size. So that's a context variable. And this one came in to me by the user, so I combined the two. So and then again, I saved the toppings as an array, and that can be used by the application. So this is just to show you how your applications can take action. And when Stefan explains, he will go over as to how AskDevOps application is using context variables.
Right? You still have 10 minutes, so we
sure.
need to move on.
Okay. So, so yeah, these were predefined intents. And let's keep going. So conversation bots, as you already know, can be used in various scenarios. You have front ends, and then you can, the input through any of these front ends will come to conversation. You can combine it with many other APIs like speech to text and tone analyzer and so on, and also take advantage of the back end to give the answer back. So input comes to conversation can go to a backend system that may be a database, it may be a corpus that is sitting in Watson, and then get the answer and come back. Okay, so it is very simple to use Conversation API. All you have is one single method that's called a service message, and you give the workspace identifier and your message, and that's about it. Okay, here's a curl command. What I wanted to, this is one single curl command, emphasize the context, which includes your conversation ID. So in one instance, you just have single ID where you're conversing back and forth. You have a system context that keeps the dialogue stack and the turn counter. So every time you're going through a node, the stack will move from root to node 1, node 2, node 3 as you go along in the conversation, and your turn counter will increment. Okay, so then, I mean, we don't have, it's not just conversation. Watson also gives you an Alchemy language API, REST API calls, to extract entities and keywords from any unstructured data. So entities, keywords, relationship between the entities, the concepts, and so on. You don't have to build the algorithms which are implemented for you and taking away the complexity. So just so that I can quickly demo to you, here is Alchemy language. And the beauty is that you don't really have to use the public model. You can also use a custom model trained on your domain and then extract the entities and build relationships. So this is very powerful for doing many kinds of cognitive applications. So here, Stefan had done a keynote in 2015. So I took that and ran Alchemy language API on it. And it definitely gave certain entities to me. So each method that you see on the left-hand side is a REST API call, and it gives a JSON output. And Stefan was talking about Professor Lawrence Cross, and that came out as a person, and the relevance was quite high. And then Devoxxed Belgium, and so on. So these are entities. There are keywords that are mentioned in here. Keywords in Stefan's note last year were definitely about Professor Lawrence Cross, but also that he's a keynote speaker, and then he's a very good author. So, and he's from Arizona. He's working at Arizona State. So all these keywords came out. So this is natural language processing for you. And if you want a custom model, what will happen is this is, I mean, I can put in, with custom model, I can put in a different text. And that text could be, let's say, about the automobile industry. And since this particular custom model is built on traffic incident report, it will use entities which are relevant to cars and traffic. So that way it will be able to better give you the relationship between entities and give you the concepts that are relevant to automobile industry. So this is a very powerful concept that you can have a custom model when you're doing a NLP. And underneath the neural network is just focused on those entities and that particular model. Any questions? Okay. So then this is the custom model that I was talking about. You have your own annotators. And this is an example where, as I was saying about the automobile industry, you will see lots of entities which are relevant to automobiles. So that's how it is. You can have it for particular industries. This is Alchemy Data API. So you can take like tons and tons of data from news feeds, blogs, and you can have targeted search and trend analysis on those. And so that's what Alchemy Data News is doing every day, taking 300K of English language news and blogs every day and building the search. So if we take a quick look at that, there is a demo here on news. It's just called News Explorer, and I thought we would want to know, if at all, more about Donald Trump. So yeah, there are lots of articles. What is happening is these articles are linked to other people. They are linked to locations. So this is a visual representation of those, and if we go into each article, then that will be highlighted on the network that has been built. But essentially what it is that a person is being linked to many articles. Those articles are linked to companies, to locations, to other people, and so that's how the network is built. And we can have different examples here. We could talk about an organization and like NASA. We could talk about Apple, Google as companies, and so on. So, and these locations are also entities. So if I click on a location, then I would have a different view of what is going on from the news feeds, what is going on for that particular location. So that's how Alchemy Data News works, is that takes the news feeds and then does all the entity and relationship mapping. So these are the pictorial representations. And then there's a query builder example as well. So then moving on, we have a unique approach in interpreting data. You can go into emotions that are much deeper than just saying positive or negative sentiment. You can have emotions focused on anger, fear, joy, sadness. And that's what we are showing in the next demo that I wanted to take you through. That's a tone analyzer. So it's here. I just gave, this is a customer chatting with an agent. And so what is the tone? And this is a very real world example. We get on the phone, sometimes we are upset with the agent on the other end, and our voice level goes up and down, and so do our words. So if we analyze the tone for this conversation, the anger is quite high, 0.86. The language style is analytical. The person on the both ends are being analytical and not just being illogical. And so the social tendencies are, well, they are trying to agree to solve a problem. So these are the scores for the social tendencies. And here's a JSON that comes back, as always, from all the REST API calls. And then at a sentence level, we can go sentence by sentence and see for anger who had a strong emotion. So the customer said, somebody created an account using my email, and I'm really angry about it. And so, and how can I delete this? So the really big red means he is expressing anger in strong tones, whereas the agent, of course, is that being milder. So same way, if you go into, let's say, joy, like there's not much joy in this conversation for sure. So it is just light yellow. So that's how the tone analyzer works. So when we do our natural language processing, we are going into emotions in the unstructured data and then really fine-tuning it. So that's what I wanted to discuss. And then we do have personality as well. So we use some big 5 matrix and then take your social data, your text, emails, Twitter feeds, and then just analyze how you are in terms of your personality. And that is used in many, many, many use cases. I would like to demo. So here is Did I have my, yes. So, I mean, this is kind of a silly way of depicting it, but I gave in my Twitter handle, and it was matched with several other celebrities in the world, and somehow, in terms of personality, I'm coming out 85% similar to this person, and 86 in terms of needs. So needs are this. So this is big 5 personality matrix. And so just how the mapping can happen, this is a trivial example to show how personality insights can be gleaned using natural language processing. Okay. Any questions? So we also have, along with NLP, we also have NLC, Natural Language Classifier, that uses machine learning algorithms to create natural language interfaces that you can add to your applications. It will interpret what is your intent behind the text you are giving to the natural language classifier. And it will return back with a classification, like a typical classification problem in AI. And it will give you confidence levels. And then based on the values returned, you can take corresponding action. So here is a natural language classifier demo that I wanted to give, if I can only go on to it. Yeah. So here's natural language classifier that is ready to classify my input. And since it is trained on weather, I asked a question. I hope it doesn't rain today because I really wanted it to be a nice sunny day. So when I asked that question, how is it classified? So it says that it is 99% confident that the question being asked is about conditions. So it was classifying into 2 buckets, whether you're talking about the weather as such. I mean, there were 2 conditions, as to the weather conditions, or you're asking about the temperature. And since I said, is it going to rain today? I hope it doesn't. It is about conditions. So it put it into that bucket. So this is a small example to show that natural language classification is very important when we are trying to do reading comprehension and trying to do abstractive summarization and answer questions. So, and then we have language translator, which is very handy and useful, and it uses the recurrent neural networks underneath to do the translation from one language to another. And so it will dynamically translate all different kinds of documents, news, patents, etc. And it will publish your documents in many languages. For example, somebody in French could be sending emails instantly in English. So this is applicable in news domain and these are the languages that are supported, and also in conversational domain. So then is speech to text, and I think Stefan has to take over.
No.
Okay. So speech to text, you could be using REST calls or WebSockets. A very unique and useful feature is keyword spotting and the keyword thresholds when your speech is being converted to text. And also offering word alternatives as the audio is being streamed with the different timestamps. So we will see an example. Also the word confidence level is very important in bringing out the final transcript. And we have a very helpful new feature added, that is customizing the language model. And that has given us awesome results. For example, if you are using speech to text in healthcare, your lingo, your language is so much different. The vocabulary is very much focused on the medical terminology, and so custom language model comes in handy. Another is you may have multiple speakers in a conversation. How do you mark this speaker is the one speaking now and not the other one? So speaker labels that are coming very soon are really useful in making out the speech signals. So here, let's look at a speech-to-text demo. So I can take an audio file as well, but let me play this sample first.
In a severe gale like this, while the ship is but a tossed shuttlecock to the blast. It is by no means uncommon to see the needles in the compasses at intervals go round and round. At almost every shock, the helmsman had not failed to notice the whirling velocity with which they revolved upon the cards. It is a sight that hardly anyone can behold without some sort of unwanted emotion.
So you see that we had different word alternatives come out with their confidence level. But what happened is that I was playing with another audio file and had given the keyword modules. So it did not spot the keywords which are in this particular sample. So let's select quickly an audio file. That is Mark Reynolds' keynote given last year, right, Stefan? So let's do that. And then here, before I really want the keyword modules.
All right. Good morning. Welcome.
So.
Java 9 is primarily going to be about modules. This is probably not news to most of you here in the room. But as part...
Let's, because I started the audio much before I typed in the keyword. So we are going to start over. Okay.
All right. Good morning. Welcome. Java 9 is primarily going to be about modules. This is probably not news to most of you here in the room. But as part of the bigger picture, well, I have...
So let me stop transcribing. So you see, Mark is talking about modules and not models, but I did want to make sure that that keyword is spotted, and speech to text told me that that keyword happened at 13 seconds and ended here, and confidence level was quite low. But combining this keyword spotting with the word alternatives here, that I can go back to 13.6 seconds easily. I can take the alternatives at that point, and then combining the two, my transcript can be much more coherent and high fidelity. So that's that. And so then there is text-to-speech. Very quickly, I will go over that you can do customization in terms of pronunciation. So our pronunciation varies depending on where we are living, how we pronounce. Also, you can make it expressive and transformable. So quickly,
Sandhya,
yeah.
can we skip that demo because we only have 22 minutes?
Okay,
and
sure.
We won't have enough time for all the other ones. Is that fine?
Yes.
So
Do you
wrap
want
it
the
up?
deck? Yes, I'll wrap it up. I mean, we can go, if there are questions, we can talk after the session.
Yeah, great, thank you. Cool, because I do want to focus also on our part, and when we give her the stage, she goes, she's so enthusiastic about this that she could speak for days. But we need to switch. Can you help me with the slide? So what I want to show is the part that I was involved with, which was really the boring part, because all the other ones wanted to develop, including Jim and Daniel. But we had to provide the Watson with data, and so I played the victim, and on a rainy Friday and weekend, I actually provided all the different intents that we need. And let me see if I'm sharing my screen here correctly. Is it this one? I think you're showing the wrong one. Great. And now we're going to lose all our time on displays. Let me mirror it. I think we're okay. Yeah, there it is. That's fine. So, so what I did is create intents for the focus we wanted to do was about Devoxx US. We were doing guerrilla marketing around Devoxx US, and that was our conversational context. So basically, like Sandhya did, is that you have you feed Watson with different examples of questions that people might ask. So you misspell it sometimes. You still see it, yeah? Or you just write it in full words like United States instead of US, etc. And that's the first thing you need to do. It's really the more questions, the more related questions you can give it, the more confidence Watson will learn your intents. Is it flickering or? Oh man, come on. Yeah, don't touch it. I need to touch my keyboard. Then the other one is the entities. So what we wanted to do is create different synonyms. So we could actually say like, okay, who's organizing it or where, etc. So what I wanted to do was what, who, where, when. And those were basically the entities I wanted to define. And you then try to declare that in different synonyms and misspelled words, etc. So again, you're making it smarter as it builds it up. This is very annoying. So what I then did is create a dialogue. So you could then actually create a dialogue within the system. So where we wanted to start with was what is Devoxxed US? Do you see it on the right? And so then it actually does recognize your intent and your entity because it now knows that it is in Devoxxed US and the entity is about the conference. And what it's nice with the dialogue is actually it opens up the box where you are within the dialogue scheme, so you can really follow the sequence. And so what you can see now is that there's two paths. You can do when, if you see my screen, or when, so when as a continuation of the conversation, or when as a new entry of a conversation. So if I do just when, it will actually continue the conversation that it knows it was already talking about Devoxxed US. So if I now type when, it just continues that flow. Okay, new cables. This is the last session of the week. I'm like exhausted. Anyway, then when, and then you could say where, and it just basically continues the flow once you see my screen. And if I type in who, there it is, and it's still flickering. It will just continue the flow. But you get the basic idea, right? So that's basically the simple conversation. Now that's where you can do the conversational bot. But if you want to do some more advanced stuff, like what is a unit test, for example, then this is not advanced enough to actually cover that. So Watson has something called retrieve and rank. What you can do there, and let me just switch to that, hardly touching the screen so it doesn't flicker too much, is that you can upload in the retrieve and rank UI all documents. Again, you're learning the system. So you need to first provide it and feed it with documents. So what I did is that I took all the Voxxed articles, I converted or I enabled an AMP plugin, which is like a mobile plugin to condense and only get the content from that page. And then I fed that article within the retrieve and rank. So you will see these different articles, as you can see it here, will actually be split into paragraphs or in chunks of information, which allows you then to link a question to that specific paragraph. So once you have fed that, you actually need to provide related questions to this. So in the article sections, there's collections. There it is, sorry, thank you, Sandhya. You then, and that's the boring part, I had to actually invent all sorts of questions which were then related to the paragraphs. And you basically train it. So you give it a question, and then you say which paragraphs actually match that question. Yeah? And that was like, I spent like really a full weekend just doing that, because the really hard part is that you can only start using retrieve and rank once you have, 150 questions. So I was going, okay, still more questions. And they were going, when can we test it? When can we test it? Oh, man, I need to provide questions. And then you can at least try it. So you have once then a ranker, which based on that information is able to give you answers. So if I say, what is a unit test? Or what is JUnit? What is JUnit? Let's try that one. It will then try to identify all the paragraphs from Voxxed, but also other ones based on that training, because it continues to train if you provide it more details to make that link. So that's just a quick demo of conversation, retrieve, and rank. And what we then did in front was to basically define a microservice which does the orchestration. It first gets the question, it sends the question to the conversation API. If it doesn't get any response, it then goes actually to retrieve and rank and try to find a response there. So that's how we did that orchestration. So that's my part. I think, Jim, Daniel, still got 15 minutes, so.
Limit has come down to 50 questions.
50?
Yes,
Okay.
50, so less.
Yeah, now she tells me that. Thank you
Too
very
bad
much,
for you,
Sandhya.
Stefan. Some people have hold like. Okay. So let's, James, I start or? Okay. So here I'm gonna show you, let me switch screen if possible. I'm using the same connector as Stefan. Hope I won't have any issue. Okay, let me try to reconnect to the robot. Okay, here I am. Just restarting the software just in case of. So here in this case, we just use all the microservices that James developed initially, and then I upgraded it in order to use several speech-to-text conversation from and the conversation system that was already there for the IBM Watson. By just using the Pepper robot as an interface. So in this case, the Pepper robot is just an interface calling the REST API as a client. Yes, hi. In this case, it just record the robot. I'm just using it as an audio recorder because the robot by itself cannot understand any words that any sentences that I'm saying to it. It record the audio, send the file to the microservices Spring Boot application that we've developed, and use behind that microservices use the speech-to-text API of Watson in order to get the sentence and also get the keywords. And then the keywords are used in the conversation API in order to start the conversation. And then the Watson returns to the microservices the conversation ID, back to the robot, and I use that conversation ID to continue the conversations with the robot, the human and the robot interaction. So let's give, that's basically it. So it's, in this case, it's a Python-based service, REST client applications, calling, so recording the sound here and asking the Devoxx to ask Devoxx using the AskDevoxx REST API call in order to send the files and get the results. So it's basically doing a REST call API from Python directly here. Why I did this here in Choreograph, which is the tool with the boxes and the links, is because I'm planning to use this primarily for the kids, Devoxx for kids, also to try to use Watson and to show them AI systems with the children so they can program this. And it's also easy for me for playing, having movement with the robot. So let's give it a try, simply. Hope this will work. Good afternoon. Okay, let's try again. Hello. Good afternoon.
Good afternoon.
Okay, let me try again. It's not the right answer. Okay, 2 seconds. Running again. Starting again. Sometimes the robot is a little bit shy. Not really shy, but okay, move on. No, it's not. Here it is. Good afternoon.
Hello, human.
Can you please explain me what is the Voxxed United States?
Okay, but to answer your question, I need the help of my friend IBM Watson. Hold on a second. Devoxxed is a conference from developers for developers, priced affordably so that all developers can enjoy this unique experience.
I see. I see.
Anything else you want to know?
Yes, when is it happening?
Okay, let me ask again the question to my friend IBM Watson.
This case it doesn't work. So yeah, sometimes it's the connectivity with the robot and sending the file to the internet is quite difficult here. Let me just try again, 2 seconds as a last test. Okay. Good afternoon.
Hello, human.
Can you please explain me what is the Voxxed United States?
Okay, but to answer your question, I need the help of my friend IBM Watson. Hold on a second.
Yeah, so here is sending the file to
This is a conference from developers
Watson.
for developers. Priced affordably so that all developers can enjoy this unique experience.
I see. I see.
Anything else you want to know?
Yes, in which city does it take place?
Okay, let me ask again the question to my friend IBM Watson. Voxxed takes place in the San Jose Convention Center.
Thank you. Thank you.
You're welcome.
Okay. So you see also below all the answers received by the robot, the rest, the JSON responses received by our Spring Boot applications. So that's basically it. Just having a REST client, a different sort of REST client here at the robot, querying Watson, basically, through our business applications. Thank you. James?
Merci, Daniel. Actually, to Sandhya's screen. Okay. So what I'm going to talk about then is is another client. Daniel just showed the Pepper client. I'm going to show an Amazon Tap or Alexa client, and so if we can see it on the screen, yes. So the architecture then is we have over on your left we have the Amazon Echo. And then we have a couple of pieces that I'll talk about very quickly. One is the Alexa Skills Kit, and another is AWS Lambda, which both run in the cloud. And then they're hitting that application that orchestrates different inputs and asks the Watson API service. So, so to use the Skills Kit to create a skills, you go to the Alexa site, the Amazon Alexa site, and there's a Skills Kit icon that then you hit, and then you can see your skills, the ones that you've created or that you own. In this particular case, I created one called Ask DevOps. And so if we go into that, we can see then the skill information. We have different tabs on the left. And so we define a skill, we give it information, we give it a name, so that arrow says Ask DevOps, and then we also give it an invocation name, and it's called DevOps. So when I say Ask DevOps to the Amazon Alexa, then it will recognize that as a skill, and then will proceed with that skill. Each skill then has what's called an interaction model. So similar to the way IBM Watson has intents and entities, the Alexa skills have intents that we can use to then kind of parse out and understand what the intent of the speaker is. In this case, I just have one intent called one-shot command, and that's going to take whatever I say and use that as the intent into the web service that we showed you. So then on the AWS Lambda side, we need to create a Lambda, which is, in this case, is a Java application that then responds to the different lifecycle commands that Alexa has, that our client has. So for example, if on start or on a particular intent, a particular lifecycle method would be called that then we would then use to then call the service that then makes use of the IBM Watson skills. And so then each lambda then has a name, it has a handler, and so you just give it different parameters for your lambda. And then the code that is behind this, if you want to write your own Amazon Alexa skill and lambda, you can see the code in this GitHub repository. It's my GitHub repository, JavaFXpert, and it's Alexa Ask Devoxx. So now I'll just go ahead and demo this really quickly. It's going to use some capabilities that Sandhya talked about and that Stefan did, where we use the conversation API that was created with dialogue, but then we also use retrieve and rank if there's no longer any path in the dialogue to answer that particular question. It will then go to retrieve and rank and try to do something. So the first question I'll ask will go to dialogue, and the second one will go to retrieve and rank. But first, we'll wake it up with the Ask Devoxx skills. So here we go. Ask Devoxx.
Welcome to Ask Devoxx. What is your question?
What's new in Java?
Java 9 is under development and will contain features such as modularity and enhanced tooling.
What is modularity?
The Java module system specifies a distribution format for collections of Java code and associated resources. It also specifies a repository for storing these collections, or modules, and identifies how they can be discovered, loaded and checked for integrity. Project Jigsaw, modularity for Java.
Goodbye.
Goodbye. Don't be a stranger.
So that's Amazon Alexa and that interface. Now I think we do have actually maybe a couple minutes for questions.
So, I mean, just to wrap up as well is, well, first of all, I would like to thank Jim, Daniel, and Sandhya for making this happen. It is a prototype, right? We really focused on specific questions as well, and it's really a matter of providing more data and more entities and intents and so on, and uploading on retrieve and rank that you can make it smarter, etc.
Yeah, Stefan, I would like also to thank SoftBank Robotics Europe for helping us with all the robots.
Thank you for that.
Thanks.
So any last questions? We still got like 2 minutes. Yeah.
Yes.
So repeat the question. Yeah. So the question is, can we have different answers for the same question?
Yes, so we can, and the way is that we have a property called random, and we have a property called selection policy. We can make that random or sequential and give many choices, and it will just choose from there. Yes, good question. Thanks.
Any other questions? Yeah, sir. So can you include an emotion in the reply? Is that? Yeah, you can distill emotion from a phrase.
Question.
Can you reply on the emotion? So you probably want to have different replies based on the emotion. If the person is angry, you want to answer differently, right?
So the question is that based on the emotions that are in the question being asked, can we reply differently? Answer is yes. You could call out in the conversation response, you could call out to Tone Analyzer API, get the analysis of the tone, whether it's angry or it's happy, and based on that variable value, you can then put your response.
So it would basically extend our microservice REST interface there. That's where you would do the switching. You first then check the emotions, and then you go to conversation X, Y, or Z. That's why we had that REST interface in the first place, to really like orchestrate which services we want to use within Watson.
Yeah.
Okay, I think our time is up. So thank you very much for attending. Don't forget to rate. And if you have any other questions, we'll be here later today and tomorrow as well. Thank you.
Thank you.
Thanks.